In this tutorial, we're gonna master read committed transaction isolation level. Really excited about this one because it's the most popular level. So with that being said, let's dive right in. Read committed is the default transaction isolation level in most of the databases. For example, PostgreSQL, OracleDB. But if it's default transaction isolation level, shouldn't you just keep it as it is and forget about it at all? Not exactly, and let's find out why. Read committed is fairly self-explanatory. It allows a transaction to see only changes that have been committed by other transactions. So no dirty reads. Let's have a look into an example where it will be a great fit. Remember a previous example from video about read uncommitted transaction isolation level and about dirty read anomaly. We had an example about McDonald's, so let's revisit it. So basically, customer comes in and selects cheeseburger and cola, and on this step, we had a dirty read. So transaction with customer has not yet been committed, but cashier already saw a partial result, which is bad, it's called dirty read. So cashier was able to see the order, even though customer haven't finally finished his purchase, he hasn't selected all of the items that he wants, and so on. And in the end, even he made rollback, so he canceled his order and didn't make any payment. And the process already began, so cashier started the order, crew members started cooking, and then food was wasted because customer canceled it. But with read committed transaction isolation level, as you can see here, this issue won't happen. So customer selected items, crew member doesn't see anything yet, and then customer decide to cancel his order, and it's not a problem. Transaction performs rollback, and cashier and crew members are not affected. No other processes have started, which is good. So I hope this example will help you to understand transaction isolation level read committed better. Okay, now I'm gonna illustrate how it's gonna work in Postgres. So firstly, let's have a look what is transaction isolation level. As I mentioned, it should be read committed, and we can simply have a look into it by this handy command, show transaction isolation level. So just enter, and as we can see, yes, it's read committed. Next, I already created tables for all of those transactions. Let's check this action. So customer comes in. We begin transaction. It's read committed, and we perform insertion. So basically, customer picks cheeseburger and cola. He made a purchase. We see here insertion, and if I will make select star from orders, we can see here two new orders were created. But if, for instance, cashier will have a look, he won't see anything yet. So this terminal is a different transaction. So for other transaction, it's not visible because here with read committed, we write and read only committed values. And if customer decides to make a rollback, so we can type simply rollback. So he cancels the purchase. He won't see anymore the changes, and also other staff won't see the changes. But if we will begin the same transaction and customer finally would make the purchase, so he will select the same items and then finally decide to pay for them, then these items will be visible for their order service, so for their cashier. And now he sees that customer made an order and these items must be cooked. So I hope it will help you to remember read committed transaction isolation level. Alrighty, let's talk about non-repeatable read anomaly. So when it happens, when a transaction reads the same record twice but sees different results, because the row has been modified by other transaction that was committed after the first read. Sounds kinda complex, but be with me, I will show you a practical example in Postgres and also sequence diagrams so you can understand it easier. So let's dive right in. Okay, let's have a look into a practical example of non-repeatable read anomaly. So let's say we have a reporting system that provides us information about balance from all accounts as well as total value. And we have a real customer that does some operation on the background. For instance, adds new money to his bank account or to his savings account. So, and the reporting system begins. So let's say it does reports periodically, and it begins. It selects all information from the accounts, and it looks something like this. So we see that customer has 3 accounts and total balance kinda 20,000. And then this client comes in, transaction with his action begins, and he adds additional $200 to his savings account. And after that, our reporting system makes transaction to calculate total balance from all accounts. And it gets this updated value also because we have read committed, it sees committed values. So we can see that this transaction was committed. Because it was affected and added to the total report. As a result, report will be not consistent, unfortunately. Here should be total balance 20,000 according to those values. And here we can see that it's 20,200. So non-repeatable read anomaly has happened. In which situation it happens? As I mentioned previously, when we do read operation twice, it gets different results because another transaction has been committed changes before execution of the second read. I hope that makes sense. Here, how it will look like in Postgres. So let's insert firstly information about all of the accounts. And if I now will make select asterisk from accounts, I see all of those values as over here. Okay. So firstly, we need to begin transaction as written here. So our reporting system starts the report and it gets all information from accounts. So we've got it, the same values as illustrated over here. And then customer comes in, starts his transaction and updates his savings account as there another $200 and performs commit. As far as we have transaction isolation level read committed, this changes are visible for our transaction A, for our reporting system. And when we do sum, so total balance, we see this value, so this operation performed. We see that total balance has changed, but unfortunately, from previous transaction, we see all changes, and total report will look as follows. It's illustrated over here. So here's the practical example in Postgres. Let's talk about lost update anomaly. Lost update anomaly happens when we have two concurrent transactions that work with the same record. So transaction A begins and makes read operation, and then transaction B begins and makes an update for the same record and commits. Then transaction A continues and makes an update for the same record and commits. As a result, the update that was made by transaction 2 will be lost. So due to this, it's called lost update. I know it sounds kind of complex, but now I will show you sequence diagram and practical example, and so you will understand it better. Alrighty, let's talk about lost update anomaly. Remember in the beginning of the course, I told you about a story where airline company selected incorrectly transaction isolation level in their database, and they sold more tickets than available seats in the plane. So this exactly the situation, and I will try to reproduce it by the sequence diagrams. Ready. So we have transaction 1, ticketed system for passengers A, and transaction 2 that tries to book a seat for passenger B. Okay, transaction 1 begins, and we check in the database, is 1A seat available, and we see that it's available, and we are booking the seat. The next, another transaction does the same. It as well checks if seed is available, and it's available because we had read committed transaction isolation level, so we see only committed changes. These changes weren't committed yet. And transaction 1 inserts into the bookings seat and passenger and commits. And transaction 2 does pretty much the same. As a result, we sold 2 tickets for the same seat to different passengers. So there are 2 passengers for the seat 1A, which is a conflict. This is an issue. And this update will be lost, and this is why it's called lost update. So this update will be overwritten by this update because this transaction will be completed as a last one. So I hope that makes sense, and now we'll implement it in Postgres. Already, let's reproduce last update anomaly in Postgres. So transaction 1 begin, we do exactly the same, then select from seats already, check if seat 1A is available, and it is, it's not booked yet. Then passenger A sees that seat 1 is available and proceeds to book it. Let's perform this update that represented over here. And another customer comes in, he starts his query. Starts his query, check if seat is available. Yes, seat is available. So now let's book it. So we booked the seat, and transaction 1 performs insertion and commits. This insertion was performed and transaction was committed, and then this transaction, the second one, does insert. So after booking, we insert into the booking table, and now do commit also. As a result, if I will go to the seats table, I see that seat 1A is booked, but who booked it? 2 passengers booked the same seat in closely the same time, but this actual conflict has happened. Here the representation of this issue in Postgres. Hope that makes sense. Also, phantom reads might happen on transaction isolation level read committed, but we'll cover it on the next video. Read committed is slower than read uncommitted transaction isolation level, but it helps to avoid dirty reads. Still, be cautious when selecting it and take into account that issues like non-repeatable reads, phantom reads, and lost updates won't pose a problem for your application. That's a wrap for this topic. In the next video, we'll have a look into repeatable read transaction isolation level and how it solves lost updates, non-repeatable reads, and phantom reads anomalies. Have a great day, and I'll see you in the next one.